Hi everyone, I'm Ritik, and today I will be presenting my talk called Demystifying the World of Serializers and Deserializers for SQLAlchemy ORM models in Python. Before I start, a quick introduction about me. I'm a software engineer at Bloomberg in London office. I have been developing with Python for a couple and a half years now. At Bloomberg, I'm working with BloombergNEF Terminal team in climate risk analysis department, where we are responsible for building client applications for better discoverability of data related to sustainable and renewable energy. This is going to be the agenda for my presentation. I'll start with an introduction about SQLAlchemy, followed by serialization and deserialization. Then we will have a look at what's the need for having configurable serializers for SQLAlchemy. This will be followed by serializers and deserializers for SQLAlchemy ORM, where I will be talking about the commonly used configurable tools, their applications and usage. Then we will have a look at the comparison of different serializers discussed in this presentation. At last, I will present some recommendations to choose the right serializer for your next SQLAlchemy application. What is SQLAlchemy? Before I start, a quick show of hands. How many of you are familiar with SQLAlchemy? OK, I can see some of you are already familiar. For those of you who are not, SQLAlchemy is one of the most powerful and flexible ORMs in Python. It's more than just an ORM. It's a comprehensive suite of tools for interacting with a relational database using Python code. SQLAlchemy bridges the gap between an object-oriented programming language and a relational database. One of its unique features is its architecture, which is split into two components, the core and the ORM, or object relational mapper. Core is the foundational layer of SQLAlchemy, which provides a SQL expression language, which is essentially a Pythonic way of writing common SQL expressions and statements. Built on the top of core is the ORM, which provides a high-level abstraction layer for mapping tables in the database using Python classes. The ORM automates many common database operations, making it easier to interact with the SQL database without writing any SQL code. Now that we have familiarity with SQLAlchemy, let's dive into the second part of the presentation, which is serialization and deserialization. While Python objects are great, they rarely represent the best way of transmitting data between different machines or communicating data across separate applications. This is where serialization comes into play. Serialization is the process of converting an object into a format which can be easily stored or transmitted. After storing or transmitting the serialized data, we want to reconstruct the object later, which is the reverse process of serialization known as deserialization. Microservices are often written in different programming languages and have different approaches to security. Think of it this way. You have a virtual representation of some data in Python. It's an object that you can interact with Python. But how are you going to transfer this information to, let's say, a web application written in JavaScript? You serialize or translate it into a format that can be understood by a different programming language. So what is the need for having configurable serializers for SQLAlchemy? SQLAlchemy focuses on the problem of connecting your Python code to an underlying relational database. It handles read-write operations amazingly, but it does not come with any serialization or deserialization support. While writing Python APIs, I often find myself repeating methods for converting a SQLAlchemy model instance into JSON, and then creating a SQLAlchemy model instance based on data I am receiving in JSON. This repetition is cumbersome. Instead of writing the same method many times over, a better approach would be to write it once and then reuse it across all of my applications. Next is data validation. Serialization and deserialization may require some pre-processing to validate the data, and that validation logic may be different depending on different data formats. Different programs may need to serialize and deserialize into and from multiple formats like CSV, JSON, YAML, and Python dictionary. Data security. Some sensitive data like passwords should only be deserialized but never be serialized for security reasons. As SQLAlchemy model relationships start getting more nested and complex, handling custom serialization becomes less flexible and more error-prone. This results in a labor-intensive process of repeating custom serialization for different models across different applications. Better, I think, is to package this functionality into a library. So to solve these problems and make our lives easy, I would like to present the configurable serialization and deserialization solutions to enhance SQLAlchemy core and ORM. I have broadly classified these into three categories. First is custom serializers, which include SerializerMixin, derived from SQLAlchemy serializer, and model serializer derived from Serialchemy. Custom serializers offer a quick and dirty solution where I'm trading rapid implementation with less functionality and customizability. Second is schema-based serializers, which include Marshmallow-SQLAlchemy and ColanderAlchemy. These are more advanced as compared to the custom ones. However, they come with the drawback of maintaining a separate schema for data validation in your model. Lastly, we have SQLAthanor, which is even more powerful and comes with a bunch of customizable options. It's an easy-to-adopt option, which you can use while maintaining all of your existing APIs and methods of SQLAlchemy. In the coming slides, we will be having a look at implementation and use cases of each of these 5 serializers. I will be focusing only on these 5 in my presentation today. First up, we have SerializerMixin, which is a Python library derived from SQLAlchemy serializer. SerializerMixin is one of the simplest and easiest way of adding serialization support to your model. It's suitable for a simple model with limited business logic, where you can enable serialization with just one line of code. SerializerMixin enables the two-dict method on your SQLAlchemy model instances, which automatically reviews the model attributes and relationships and converts it into a Python dictionary. SerializerMixin also comes with basic customizability, where I can exclude or add some extra fields in the serialization output. You can even define the only fields to be presented in serializer output. This serializer is not intended for applications demanding deserialization support. Also, it is not the most ideal solution for a complex SQLAlchemy model with a lot of business logic, especially when dealing with nested or deeply structured data. Let's understand the usage with a code example. Simply inherit SerializerMixin in your SQLAlchemy model class definitions. We define a serialize-only attribute, which includes the only attributes you want to include in the serialization output. Calling two-dict function on item object converts it automatically into a Python dictionary. Next up, we have model serializer, which is a Python library derived from Serialchemy. Similar to SerializerMixin, it's a simpler and maintainable serialization solution. Unlike SerializerMixin, it also provides deserialization support. Model serializer enables dump and load functions for serialization and deserialization respectively. It also comes with basic customizability, where I can exclude certain fields from being added in the serializer output. You can even dump fields as nested objects in serialize output. Let's take a look at this code example to see how this works in practice. We start by defining an employee SQLAlchemy model class instance, which actually maps to a record in the database with given ID, name, and birth date. Next, we define the serializer by importing it from Serialchemy and calling it on employee SQLAlchemy class. Serializer.dump function converts employee class object into a JSON-friendly dictionary. On passing this JSON-friendly dictionary as a parameter to serializer.load function, it deserializes it back to employee object. Next up, we are going to dive into the second category of serializers, which is schema-based serializers, and the first one is Marshmallow-SQLAlchemy. Before diving into the details, let's understand what Marshmallow is. Marshmallow is a popular Python library for object serialization, deserialization, which comes with built-in data validation support. It provides a simple and convenient way for converting Python objects into JSON, XML, or other formats suitable for transmission and storage. Conversely, you can take serialized data and convert it back into Python objects. This means serialization and deserialization is not only limited to SQLAlchemy models with Marshmallow, but you can serialize any Python object. Key features of Marshmallow include schema definition. Marshmallow allows you to define a schema, which is essentially a blueprint for how data should be serialized and deserialized. You can specify different keys, fields, constraints. Second, we have data validation. This is important for ensuring only right and properly formatted data is stored or transferred. Marshmallow also supports nested schemas. This is important for handling complex relationships, such as one-to-many or many-to-many relationships between objects and data structures. Marshmallow SQLAlchemy is SQLAlchemy's seamless integration with the Marshmallow library. With Marshmallow SQLAlchemy, you can automatically generate schemas as they are derived from SQLAlchemy models. Once you have the schema, it can be used for efficient serialization and deserialization, and it also comes with built-in data validation support. Marshmallow SQLAlchemy inspects the model attributes to automatically generate fields of a schema. This can result in processing overhead, especially in large-scale, high-throughput applications where I'm dealing with large volumes of deeply structured and nested data. Marshmallow SQLAlchemy streamlines data serialization in Python. Let's see how this works in practice. We start by defining a SQLAlchemy model class user, which essentially maps to the user table in the database with given ID, name, and email fields. Then we define a schema using SQLAlchemy auto schema. User schema directly maps to the user class. In this code example, I have initialized the value of load instance variable as true, which means I am also enabling deserialization to model instances. Once I have the schema, I can call user schema.dump and load functions for serialization and deserialization respectively. This part is pretty similar to what we have already seen for model serializer. Marshmallow SQLAlchemy allows fine-tuned control over serialization. Let's understand the key customizations with a code example. First is selecting specific fields or field exclusion. Similar to other serializers, you can exclude a certain field from being added in the serialization output. In this code example, I've excluded password from being added in the serialization output to hide sensitive data. Second, adding custom fields. In this code example, we have a get full name function, which dynamically combines first and last name to create the full name for a user. In this way, we can add more custom fields for our model. Third, handling nested relationships. Marshmallow SQLAlchemy provides built-in support for handling nested relationships between models using the meta.nested property. And lastly, custom data validation. In this code example, I've added a validation for email address to validate @ character is present in the email address. If not, we will raise a validation error. In this way, these features help in creating more secure, efficient, and structured API responses. Moving to the fourth serializer, which is ColanderAlchemy, another schema-based serializer. Before diving in, let's take a look at what Colander is. Colander is a lightweight yet powerful Python library for object serialization, deserialization, with built-in data validation support, pretty similar to Marshmallow. Colander helps define schemas that enforce structure, validate input, and transform data into the right format. Key features with Colander include schema definition, where you can define a structured data format with different custom validators for ensuring data correctness. ColanderAlchemy bridges the gap between SQLAlchemy models and Colander schemas. With ColanderAlchemy, there is no need to manually create Colander schemas for your models because it's all handled automatically. ColanderAlchemy is primarily focused on data validation rather than serialization. This makes it less suitable for complex use cases where I'm handling deep nested relationships because it will require more manual work compared to Marshmallow SQLAlchemy, which comes with built-in support for handling deeply nested data. Also, ColanderAlchemy has fewer tutorials and slower community-driven improvements, which makes troubleshooting and finding best practices a little harder. While ColanderAlchemy automatically generates schemas from models, customization helps to fine-tune validation and enforce better data validation beyond database constraints. Key customizations include overriding fields. With ColanderAlchemy, you can modify types as well as add default values. In this code example, I have added a default value of 21 in case age attribute for a user is missing. Second is adding validators. You can add custom validators, which is important for ensuring stricter data validation beyond database constraints. In this code example, I have added a validator for username to ensure that the name of the user is between 3 and 20 characters. Similar to other serializers, you can exclude a certain field like a sensitive data from being added in the serialization output. And lastly, we have renaming fields. In this code example, I have renamed username to user_name. This is important for ensuring things like API compatibility. With these customizations, ColanderAlchemy becomes a powerful tool for building robust, validated, and well-structured APIs. This brings me to the last serializer for today, which is SQLAthanor. SQLAthanor is designed to extend SQLAlchemy to provide it with serialization and deserialization support. It acts as a drop-in replacement for SQLAlchemy. You can continue to define your models just as you would with SQLAlchemy ORM, but now they would also support serialization and deserialization. SQLAthanor provides seamless integration with SQLAlchemy. This means you can maintain all of the existing APIs, methods, functions, and functionality of SQLAlchemy ORM. This makes SQLAthanor a non-intrusive addition to your model. With SQLAthanor, we can decide which serialization formats we want to support for which models. It supports serialization and deserialization across the most common data exchange formats like JSON, CSV, YAML, and Python dictionary. This flexibility allows you to tailor serialization to specific use cases. SQLAthanor also allows you to control which columns or attributes will be included in the serialized output. You can even define different sets of columns for different formats, making it highly adaptable. It supports pre-processing before serialization and deserialization, which is useful for data transformation and validation. This is important for ensuring only right and properly formatted data is stored or transmitted. And last point is custom validation for deserialization. SQLAthanor allows you to customize how data is validated before deserialization. This is important for ensuring data integrity while converting input back into database objects. Let's see how we can use SQLAthanor. To do that, we start by adding configuration in SQLAlchemy model class definitions. To do that, simply add a serialization attribute in your model class definition. Serialization attribute consists of a list of one or more attribute configuration objects where you actually explicitly define which columns should support which format. You can even define things like what function needs to be called on serialize or on deserialize. Once you have set up the configuration, all you need to do is call a toFormat function on your SQLAlchemy model instance for automatic serialization. Format can be CSV, JSON, YAML, or Python dictionary. In this example, I have used toJSON. Unlike serialization, there are actually two different ways of deserialization. The new from JSON function operates on a SQLAlchemy model class and creates a new SQLAlchemy model instance based on data you are deserializing. On the other hand, update from JSON function operates on a SQLAlchemy model class and updates the attributes of that object based on data you are deserializing. Now that we have an understanding of different serializers, let's dive into the comparison of the options we were looking at today. First is ease of use. Custom serializers are simple, but they require manual effort. Schema-based serializers require schema definition, which adds an additional step in serialization and deserialization. SQLAthanor makes this process fully automated, making it the easiest option to choose. When it comes to validation, custom serializers require manual validation. Schema-based serializers provide strong validation, including field-level validation and nested validation, whereas SQLAthanor lacks advanced validation support when it comes to nested models or deeply structured models. Moving to flexibility, custom serializers struggle with complex models and provide limited customizability. Schema-based serializers provide high customizability because you can define the configuration for serialization in a separate schema, separately from your SQLAlchemy model definition. This allows and gives the developer more control over how data is handled, whereas SQLAthanor provides moderate customizability. Lastly, scalability is a key factor. Custom serializers struggle with complex models. Schema-based serializers provide good scalability, especially in larger scale applications where I'm dealing with a lot of deeply structured and nested data. However, this comes at the cost of slow performance. SQLAthanor is a good option for small to mid-sized application or for applications dealing with lightweight flat models. However, it is not the most optimized solution for an application where you have to deal with nested data or deeply structured data, because that needs to be handled manually, unlike other serializers. This brings me to the last slide of my presentation. So what's the right serializer for your application? And the answer is there is no one-size-fits-all serializer. Choosing the right serializer depends on your application's performance requirements and complexity. And it is always a good idea to experiment with a few options before picking the right fit for your application. In general, custom serializers like SerializerMixin and Model Serializer are good for simple prototyping applications where I'm not dealing with a lot of complicated business logic. Particularly, SerializerMixin is not good for applications requiring deserialization support because it is not supported. Schema-based serializers are good for applications where I'm dealing with a lot of fine-grained data validation control, or in applications where I'm dealing with a lot of nested and polymorphic models. Lastly, SQLAthanor. This is a good option for performance-focused applications and lightweight flat models. This is not the most ideal solution for a deeply nested or deeply structured data model. Thank you.